Hello and welcome to this demo video. My name is Gaurav Saxena and I'm joined by Steve Walker. Together, we will walk you through the latest capabilities that help you simplify unstructured data analytics using BigQuery. Unstructured data is expected to be the majority data type in coming years. However, only a small percentage of its value is realized today. One of the big reasons why unstructured data analytics hasn't gone mainstream is because the AI ML tools required to unlock this value are often separated from the data warehouses. And bridging this gap requires expensive infrastructure management and building specialized teams, which means that organizations have to severely constrain the use cases that it can be prioritized. Our goal is to help customers make sense of all their data. Earlier this year, we announced Big Lake, which helped customers unify data lakes and warehouses. Building on it, we are now excited to announce Object Tables, which provide a structured record interface to bring unstructured data analytics to BigQuery. Object Tables enable SQL interface for unstructured data and make it available to existing BigQuery processing framework. Customers can now take advantage of Google's unique AI services in speech, vision, docs, and language right from the BigQuery experience to run analytics on their unstructured data. Not only that, customers can use existing familiar mechanisms to secure, search, govern, and share unstructured data right alongside with their other BigQuery data without needing to learn or deploy new tools. To show you exactly how this is done, I will hand it over to Steve for a demo.
Hi, everybody. I'm Steve Walker. I'm a developer relations engineer with Google Cloud. Today, I'm going to demonstrate how you can build a machine learning model using the new object tables in BigQuery. And our sample today will be based on our Google merchandise store data. This is available in our public data set in BigQuery. There it is right there. Do a quick little preview. Dates, events, timestamps, keys, all that kind of fun stuff. Product IDs, sales information, dollar figures. What you're not going to see in this table are the images. Images is what we're looking. The images are what we're looking to use today. They're in a Google Cloud storage bucket. There's the bucket. There's all of our images, approximately 400 of those. Take a quick look at one. It's like a nice Google Cloud sweatshirt. Fantastic. Now, if we had tried this maybe 6 months ago, and we're looking to use unstructured data in BigQuery and images, you'd had to fire up your favorite programming language, whether that was Java, Go, Python, etc. You'd have to grab those images from Google Cloud Storage, extract the embeddings, upload those to BigQuery, and same goes for Cloud AI Vision Services. You'd have to call those functions, get the results, upload those to BigQuery, combine everything. It's a very time-consuming multi-step process. With object tables and remote functions now, you can do that all from within BigQuery. You never have to leave the platform. And we're going to demonstrate that right now. All right, first thing we need to do is we need to create that object table, that big leg table. That's exactly what this statement does. Here's my storage bucket I just showed you. You give it a nice name. Let's run this. Let's do a quick select on top of that. There we go. We asked for 10 rows. There's our URIs. Here we have our updated column. We'll just know that image was updated. So that's all working great. It tells us that it is an image, JPEG. So what can we do with this now that we have access to it in BigQuery? Well, we can call our Cloud AI Vision services and use some of their functions like detecting labels and images, detecting objects and images, logos, a bunch of other functions in Cloud AI you could use that Garth mentioned as far as natural language processing, uh, images, which we're doing here, text, etc. All right, so let's just do a quick sample query here. So I'm just grabbing 5 images from our bucket. We'll run that through Cloud AI really quickly. While that's running, at the end of this, once we create our model and our data set, we'll be able to go here to our Analytics Hub, and we'll actually be able to share that data set in Analytics Hub, and then external partners, organizations, and customers will be able to use that. Okay, let's go back and check our results. So we passed in 5 images. Here are our results here. Here's all of our labels from the first image. See some tableware, some cups. It says colors. We got some aqua, all that kind of good stuff. Looks like we have some type of drinkware here. And then of course, we asked it to identify objects. So we identified a mug, identified a bottle, another bottle, earrings apparently. And it also checks for logos. We asked it to do that. El Camino College, that's interesting. G Suite, etc. So that's great. So it looks like the Cloud AI functions did really well, returned our information we were looking for in JSON. We can now parse this, and BigQuery has native JSON support, and combine that with our business data. Now, I did, prior to that, we'll create a table with all of the image information as it relates to calling these functions. So that now lives right here in this table vision demo. I'm going to quickly walk through how to create a search index on top of that. So if you have millions, hundreds of millions, billions of images or results from, say, Cloud AI services, you want to search them, you need something very efficient. So we built Big Search to do that. First thing I'm going to do is I'm going to drop the index that already exists. And we're just going to recreate it here. I'm passing in my new table name. I'm telling it what column I want it to index. I want it to index the label column. We'll just run this really quickly. It's very fast. So it's indexing the JSON. There we go. We're already done. How does it help us? So now when we do a select statement on this table, we can pass in this search primitive here, tell it the column, which is labels, and give it a search parameter. There it is. I'm looking for a mug. Let's run this. There we go. So we got our labels, drinkware, coffee cup, porcelain, pottery. That's great. Let's go double check here. We'll check Cloud AI's work, filter on that image name, open that up and see if it is in fact a mug. There you go. San Francisco, California. We have quite a few offices there. So that's great. We're able to extract those image embeddings. We were able to run that through Cloud Vision AI, and it was able to identify that as a cup with a bunch of other stuff from that image in Google Cloud Storage. Okay, let's jump into to another topic related to object tables and Big Lake, which is security and row access. Let's just do a sanity check here in our table. We'll run this query. I asked for 50 rows back. It looks like it gave me 50. That's great. Now, let's apply a row access policy and limit what will be returned to a user. So I'm going to create a policy. I'm going to name it only new images. And all I want to see is images created after October 1st. So here is our filter that we're using to set that, where that column is greater than October 1st. You could also protect data that was private, confidential, PI data right here. You could filter on that. You could filter on basically anything that BigQuery supports. That's awesome. Let's create our row access policy, and then we'll rerun that select star. And note that I'm granting it to me. That's me, Steve. Now let's do our same select star. We asked for 50 rows before, we got 50 rows back. Now we only got 2 rows back because they were in fact created after October 1st. There they are. That is great. You can apply as many of those policies as you like. I'm going to go ahead and drop those policies. So next time I run this, I'll get all my data back. Okay, so to quickly recap this part of the demo, we created a Big Lake object store table. We demonstrated how to call Cloud AI Vision functions, whether that's detecting labels, logos, etc. You can use Cloud AI speech, natural language, text, all that good stuff right from BigQuery using SQL. You never have to leave the platform. And we did big search. We indexed those JSON results from Cloud AI Vision, and then we applied a security policy to the table. It's quite easy, and we demonstrated how effective that was. All right, let's jump over to our machine learning model in BQML. And you'll remember that we are using the Google Analytics data. This is what it looks like right here. Right, I have a obfuscated user ID. I got an event date, some categorical variables like continent, like geography, mobile, and brand name. What we're trying to predict is this purchase column. 1 is true, 0 is false. So I already built this model. Show you the results in 1 second. But what we're really here to do is to combine that unstructured data with the business data, which is what this model build does. Take just a second to display because there's a ton of columns here. So what I did was I imported a TensorFlow model from TF Hub. TF Hub is an open source site by Google with hundreds of great TensorFlow models out there. I copied that to my Google Cloud Storage bucket. I created a model of type TensorFlow in BQML. There it is, called Next Images. And with that, I can take each one of those images from the merchandise store, extract the embeddings. It'll return a nice array of vectors. There it is right there, the feature vector. This particular TensorFlow model returns 1024 vectors. A lot of columns, a lot of data. Hopefully that'll help our model. And you do that with just a simple ML predict, and you pass in that TensorFlow model that I just showed you that I created. All right. So the option to create that model with the image data is all right. Our model, our decision tree model we're building with the images, it's right here. And if we look at our training data, you remember our other model had about 20 columns. There's our purchase, our label, our target variable. Well, now we've added all of those image vectors, that TensorFlow model. So we have 1,000 plus new columns. That's great. So we rebuilt that model. How do we do with the model score? So the boosted tree, the decision tree with no image features, had a rock score, area under the curve score of 0.77. Pretty decent. Let's call that a B minus. We added those image features and we improved the model score by over 3.5%. That's great. I think it's fair to say that would be roughly equivalent to a new categorical feature. So that's a very good result, and that's without any hyperparameter tuning, any other optimization that we could do in BQML. So I'm pretty happy with that. So we built our model. We've used the unstructured data. We've combined that with our business data. We've got this new data set that contains all of that. Now, if I want to share that in Analytics Hub, it's quite easy. I would just give it a nice name here. Maybe merch store info. I'm going to skip all the contact information. Definitely going to call this retail. And definitely came from us, Google. I'm going to skip the icon. You can upload a nice icon. You can give it a nice description. Google store. Things like that. And I'm just going to type the name of my data set. There we go. And I'm going to save it. So now that data set is in Analytics Hub. I'm going to try to go back and refresh this. This page has been a little slow. Hoping it quickly refreshes here. All right, and there's our Big Lake Demo Exchange. It now has the one listing for our new data set, and your partners, other organizations, external to yours can now access that. You can share that with them and all the goodness that comes with Analytics Hub. Okay, to quickly recap, what we've done here is we showed you how to access, how to analyze, and how to build search indexes and models using Big Lake and object stores. All this can be done in BigQuery without leaving the platform, which is great. Hoping to make your lives a lot easier. When you have a chance, check out the documentation around this new product. And thanks for watching, and hope you enjoy next. Cheers.